Okay, folks, we're going to go through 5-1 notes. We're going to get all the way through it today. It's really kind of, I mean, there's a lot of examples, but it's really kind of short. It's like substitution elimination. This is like algebra 2 stuff. We do eventually get to stuff that's just like a touch more work, and that is like solving 3 equations at a time. Let's see where we're at. Like this guy right here, like a 3x3, where you have x, y, and z, and that gets a little, yeah, example 6. That gets a little bit more involved, but it's like the same steps over and over again. So, starting with like example 1, these 2 equations are linear functions, right? Like they just have an x and a y, right? And so if you look at what's above, what could happen and what most of the time happens is you have one solution where the 2 linear functions are just like across from each other, right? And you have like one dot. So you're trying to find the solution where they cross. Okay, sometimes those 2 lines will be in disguise like parallel to each other, in which case they will never touch, so you have no solutions. And sometimes those 2 functions are the same line, like let's say you have like x plus y equals 2 and 2x plus 2y equals 4. Well, those 2 are the same equations. They're just on top of each other, and you have infinitely many places where they touch. So we'll see what that looks like. All right, example 1, solving. They want you to use substitution to solve this one. Example 2, we'll do elimination. Substitution. Okay, we got to solve one of the equations for one variable. Okay, so I have options. I have 4 options. I could either solve for this x, this y, this x, or this y. One of those is going to be the easiest one to solve for. Which one? You could solve for negative x, but then I'd have to divide the negative over, so he's the second easiest one to solve for. I'm going to solve for this y right here. That makes sense? Because all I have to do is add the x to the other side, right? So y is equal to x plus 3. Does that make sense? Okay, I don't have to divide by a negative. I don't have to divide by 3 or divide by 2 or anything like that when I solve. So he just is nice. Okay, then the x plus 3 is going to get plugged in for y right there. That makes sense? So I've got 3x plus 2, and instead of y, it's now x plus 3 goes in that blip, equals 11, right? Okay, then I'm going to distribute my 2. So 2x plus 6 is in the middle. Then I'm going to combine my x's. 3x and 2x is 5x. I'm going to subtract my 6 to the other side. So 5x equals 5. And x is 1. Okay, now you have options. We got to solve for y also. You have options. You can plug x into this top equation. You can plug x into this bottom equation, or you can plug x into this little solved for equation. And that's the easiest one. I'm going to plug 1 in there, and if I plug 1 in there, y equals 1 plus 3, or y equals 4. Okay, now I like to write my answer as an ordered pair, so like 1 comma 4, and that ordered pair, that dot, 1 comma 4, is going to be the place where these 2 lines cross each other, right? At 1 comma 4. Good. That's substitution. My favorite is elimination. I like elimination way better than substitution, okay? Elimination, you have to eliminate a variable, but you might have to like multiply either the top or bottom or both the equations by something. Okay, so we have to decide, do we want to eliminate the x's or eliminate the y's? Sometimes it's obvious that one is easier than the other. I don't think one is obviously easier than the other. Which one do you want to do? X's or y's? You want to do y?
One's already negative.
Yeah, the y's one's already negative, so that's kind of appealing to me. So if we do the y's, we'll have to make both of them 12s. So the top equation we'll have to multiply by 3, the bottom equation we'll have to multiply by 4. Okay, now I'm just going to put them off to the side. So like 9x minus 12y equals 3 is your top guy. Your bottom guy, 8x plus 12y equals 48. And then you're just adding those equations together. Okay, so the y's should cancel, right? How many x's? 17x, okay, equals, and 3 and 48 is 51. And if you divide by 17, that's 3, yep, x equals 3. Okay, then I'm going to plug back in, and I can plug back in wherever I want to. Both of them are going to be kind of gross. Which one do you want? Top one or the bottom one? Bottom? Okay, because of the plus sign. I like it. 2 times 3 plus 3y equals 12. Okay, 2 times 3 is 6. If I subtract that 6 over, I get 3y equals 6. So y equals 2. And so 3 comma 2 is going to be your place where those two linear functions are going to cross each other. Using elimination, same thing. It was, you know. Okay? All right, now what if we end up with weird answers? Okay, so that's like this one. Do you want to substitute or eliminate? It doesn't
Eliminate,
eliminate, yep.
but they'll both eliminate.
Yeah.
So it doesn't matter.
So, it kind of, okay, so you're right, they both will eliminate, but we've got to keep going because we've got to see if we end up with 0 equals 0 or 0 equals a number, right? So, let's say we're picking on x's, right? What do we have to do in order for the x's to eliminate? I'm gonna multiply the top equation by 2, right? I'm gonna put him down below here. So this is 6x minus 4y equals 8, right? And if I add that to the second equation, my x's go away, my y's go away, so what do I have left on the left side?
0.
0 equals
15.
15. Okay, when does 0 equal 15? Never, right? So what do we have going on here?
No solution.
No solutions, right? That's not gonna be an answer. So what's happening to these linear functions if they have no solutions?
Oh, this one's a little blurry.
They're parallel. We have two lines that are parallel in this case, right? Okay, so no solutions. Got it?
Is that an 8?
What?
Next page.
Yes.
What?
An 8.
Oh, 8. Yeah, 8x minus 2y equals negative 4. Oh, I'm making myself dizzy. Okay, so you want to do elimination here as well? Multiply the bottom by 2. Ugh, that's gross. So I'm going to rewrite this top one too.
Oh, so it's gonna be 0.
The top one, yeah. Top one is 8x minus 2y equals negative 4. And the bottom one, if I multiply 3 by 2, is negative 8x plus 2y equals positive 4. Okay, if we add those together, we end up with 0 equals 0. And when does 0 equal 0?
Always.
Always. So we have
They're just overlapping.
infinitely many solutions. They are like the same line on top of each other. One is just multiplied by 2, right? So infinitely many solutions is what we've got going on there. Make sense? Okay, now that same situation happens. I'm going to skip example 5. Can we do that? Let's go to example 6. That same situation can happen when you're dealing with 3 variables. So again, if you get to the point where you get 0 equals 0 or something, infinitely many solutions. If you get to the point where like 0 equals 15, no solutions. Or you could get an ordered triple. Now, here's how you deal with these, okay? We have to decide, and we have to pick on one variable to eliminate 2 times, okay? But it has to be the same variable. So if I look at these, what I'm gonna do is I'm gonna pick on the top and the first and second equation is usually what I do, right? And I have to eliminate a variable. Maybe we decided we're gonna eliminate z, right? Then I have to add 2 more equations together. So I could do the first and the third equation added together, or I could do the second and third equation added together. It doesn't matter, right? I just have to pick 2 equations and then 2 more equations, okay?
Let's just do Z. and
So
then
let's just do
1
Z?
and 2 and then 2 and
Okay,
3.
sure. So if I do z, let's do the first and second equation. I'm gonna have to multiply the second equation by 6, right? I'm gonna put him up above so that we can see him, right? So if I multiply the top one or the middle one by 6, that will be 12x plus 6y minus 6z equals 12. I'm gonna add those 2 together. You see what I'm doing? Okay, so if I do that, I end up with like 15x plus 15y. The z's are gone, equals 15. Hey, that's kind of nice. Okay, so we just multiplied this guy by 6, right? And we did this guy. So we're gonna add this one and this one together. So if you want to rewrite that guy over here, I would put him over there, and then you can add them together. So now the z's are gone. Okay, so now the variable that we just eliminated was z, so we have to eliminate the same variable again, or this doesn't work. So if I add the second and third equation together, yeah, those z's eliminate really nice, like they're already eliminated, right? So how many x's will you have?
3.
3x, okay, plus
2.
2y, the z's are gone, right? Equals
4.
4. Okay, now,
Where'd you get 3?
sure. So now we're adding just these 2 equations together. So 2x and x makes 3x. Y and y makes 2y. Z's are gone, equals 4. Yeah. Now.
We gotta eliminate again.
We gotta eliminate again.
So, be easier to eliminate x,
Yeah,
-5.
yeah. So now we gotta eliminate with x and y. So we're gonna multiply this guy by -5 to get that to be 15. Okay? We're down to 2 variables now, okay? So -15x minus 10y equals -20. And then I'm gonna add these two together. Okay, so 15x minus 15x, that's gone. I have 15y minus 10y, so that's 5y equals -5. And then I divide by 5. Yep, and y equals -1. Perfect. Okay, now we're almost done. Now we got to work backwards. So I got to take this y, I got to go back to one of these equations, solve for x. Then I'm going to take the x and the y, go back to one of these equations and solve for z, right? So we're close. We're getting close. Which one do you want to plug into? The bottom one, like this one right here. 3x plus 2y equals 4. So 3x plus 2 times -1 equals 4. Okay. 2 times -1 is -2, but if I add 2, then that is 3x equals 6. So x is 2. Now I got 2 of my answers. I got to get one more. You gotta plug -1 in 4. Oh wait, it should be 3x plus 2y equals 4. Yeah. So you took 2 times -1, so it's -2, equals 4.
Are you done?
Yeah, and add the 2, divide by 3. Okay, now we gotta bump back to our first 3 equations. Which one do you wanna plug into?
Number 3 is
I want to plug the
easiest.
bottom one in. X plus y equals, or x plus y plus z equals 2. That sounds good. X is 2, y is -1, plus z equals 2. That's a lot of missing weird stuff. So we're just plugging into that bottom one. 2 and -1 is just 1. And if I subtract that 1 over, z is 1. So, final answer, I write it as an ordered triple. So x goes first, then y, then z, 2, -1, 1. And that is going to be the place where all 3 of those cross each other. Okay? Now, a thing with 3 variables, this isn't a linear function, it is like a plane if it has 3 variables, right? X, Y, Z. And so three variables are crossing each other at one point. This is like the corner of a room where all 3 of them are touching, right? And that's the point that we just found. Now, you could have a weird thing happen where they're touching at a line, right? In which case you get a weird funky answer like 0 equals 15 or whatever, right? You could have all 3 planes be exactly the same. So this is where you have infinitely many solutions, right? Where they're like laying on top of each other. You could have all sorts of weird things happen. And this is what you get when you have like 0 equals 0 or 0 equals 15 or whatever like that, right? So the one that we're solving for is this guy right here, where you have an actual number. Now, I will tell you that on the homework assignment, none of your answers should come out as being decimals or fractions. They should all come out as whole numbers. They might be negative, like this one had a -1 in it, but they all should come out to be nice. Okay, unless it's like the 0 equals 0 and 0 equals 15 scenario, right? Okay, do we need to do any more? Should we stop?
Probably.
Okay, all right, we'll stop there. Okay, that should be enough for you to do what you need to do. Okay, all right, goodbye people watching this video.